Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leaders series, Timber Durability Essentials for Engineers. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, Wood Solutions. Wood Solutions is a not-for-profit initiative established in 2010 to provide independent technical information on timber and wood products for building professionals. Supported by Forest and Wood Products Australia, it offers comprehensive resources, including case studies, technical publications and design guides to promote timber use in construction. Wood Solutions also hosts seminars and workshops to foster sustainable and innovative building practices. Its mission is to help architects, engineers and other professionals to make informed decisions about timber, contributing to the growth and development of the design and build sector. Today, we will hear from one speaker, followed by an audience Q&A, and I encourage you to send questions through via the chat box. I'd now like to welcome our speaker, Nick Hewson. With over 18 years of experience in the construction industry, Nick is a chartered structural engineer and timber engineering expert. Nick has led diverse projects from domestic renovations to multi-billion-dollar civil and structural developments in the UK and Australia. As the director and founder of Arbораlis, a consultancy specialising in innovative timber solutions, Nick is passionate about promoting timber's role in a low-carbon future, and he co-founded Timber Dialogue, a community organisation supporting timber use in Australian construction. Nick has a strong background in engineered wood products and structural dynamics and has contributed to multiple publications on timber design. Please welcome Nick Hewson.
Thanks very much for the introduction. It's great to be here today to talk to you. I'm going to be talking on timber durability essentials for engineers on behalf of Wood Solutions. My name is Nick Hewson. I'm a qualified structural engineer registered in most states in Australia. I've got 20 years of experience, particularly focused around timber structures. I gave a presentation as part of Engineers Australia a few months ago on hybrid timber buildings, and a lot of the conversation, a lot of the questions were focused around durability. So this session wanted to sort of do a deeper dive into that to give a better overview of durability and some of the ways that I see it and deal with it. Today we're going to kind of cover quite a lot of ground. Look at code requirements for durability, what's so important about it, different hazard classes, timber treatments, different ways of mitigating that, particular focus on water management and termites, and then some ideas for other reading. So a few of the things we won't really cover today, not looking at non-structural elements, not really looking at accessing existing structures or any kind of really unusual heavy industrial maritime things. And while the presentation will cover domestic housing, the focus is more aimed at larger timber buildings, and we'll see a bit why later on. As I said, I'm part here on behalf of Wood Solutions. So they're a non-for-profit company that's resourced by Forest and Wood Products Australia. So their remit is to promote forest and wood products to the building sector. They offer a whole range of things from webinars. They have a lot of technical design guides on their website that you can go and download for free, written by industry experts, and we'll be referring to a few of those later on. They also have a project portal, which is a reference of hundreds of buildings from all around the world that you can search for by project type and other variables, which will give you some inspiration. And why are we here? Why are we talking about timber? Timber is a sustainable, renewable resource. It stores carbon for the life of the building, and has been shown to improve wellness and enhance moods and things like that. So it's a wonderful material, one that I'm incredibly passionate about myself, and I'm really pleased to be able to come talk to you today on the subject of timber. So when we look at timber, durability has become a real kind of pet topic of mine over the last few years. So wood can last an incredibly long time. As you see here, there are examples of buildings which have stood for over 1,000 years, been well looked after and maintained. But if we don't look after it and maintain it, then wood can deteriorate. And what we want to talk to today is some of the mechanisms we can use to help prolong the life of our timber buildings and protect this wonderful material. So starting at code requirements, when you start to look into the NCC, it's pretty vague on the topic of durability. It doesn't have any specific clauses relating to it, and puts the onus back on individual material standards. So you're looking in the NCC Volume 1, Clause B1D4, which refers to timber construction and refers back to the design standards. There's a lot more information there around termite risk management, and we'll talk more about termites later on. But if I dive into AS 1720 Part 1, it has some clauses on durability at the start. But again, they're somewhat vague. They focus more around treatment for termites and things, but just highlighting a few key clauses in there. Talking about satisfying the strength, stability, and serviceability requirements for the design life of the structure, and we'll talk about design life and things a bit later on. And on the one there I've highlighted in red, any anticipated maintenance program should be specified, which is an interesting one, and we'll talk again a bit more about that later. But I think that's something I don't think many engineers will be specifying in their on their projects, on their specs, and that's something that I think we'll cover during the presentation. So 1684 for domestic housing. Actually offers a lot more information. It's quite practically focused, has an Appendix B, which is all focused around durability, talks around different hazard classes of timber based on the level of exposure to weather or the ground, and kind of gives a lot of classifications for that. Also provides some sort of practical tips and details, and more of those sorts of things are actually contained in some guidance documents. So documents, technical design guides 5, 13, and 21 from Wood Solutions, again freely available on their website, offer a lot of kind of tips and advice about particularly external timber. There's a lot of good detailing advice and information around timber species and things like that. So you get hazard classes, so they're H1 to H6, getting progressively more aggressive environments. So H1 and H2 are sort of internal protected, H2 being protected against termites and the like, with H3 being outside and above ground, subject to some weathering. So these are the sort of main ones that we will be kind of focusing on. H4 and above are kind of a lot more specific. What we do kind of need to bear in mind is design life versus accessibility. So here's a useful guide from the BCA, which talks about the design life of your building and how kind of accessible and economical to repair different elements are. So most buildings we're going to be getting involved in are in this sort of normal area. So 50 years design life, and it's providing kind of recommendations around what design life of different kind of sub-assemblies and components should be. So looking particularly at that kind of last column. So if it's not accessible or not economical to repair or replace, that should be should be kind of assuming, designing something to last the design life for the building. So when it comes to timber treatment, there are three main options to protect against decay. It's either eliminating the contact with the moisture through coatings, but remembering back to that slide just before, if there is a maintenance requirement for those, according to the code, we should be kind of specifying those on our drawings, or at least kind of drawing attention to it in some way. Using naturally durable species, particularly for external timber, or using timber that's been preservative treated to the appropriate hazard level. So looking at different life expectancy. So the Wood Solutions Design Guide will give further information on different species suitable for different classes, but just looking at outside, above ground, what are the kind of different species that we can use for those. So if it's outside, above ground, and you want it to be lasting 40 plus years, you're in those sort of class 1 species, which are your ironbarks, your spotted gums, your blackbutt, merbau sort of timbers. So obviously those ones are kind of rarer and more expensive. So we need to have these sort of nuanced conversations with our clients around picking the appropriate timber for the job. Timber treatment. Preservatives can be either water or soluble based. There are a range of different treatments out there offered by different manufacturers. One thing I will say about treatments is checking the compatibility with finishes and any ESD requirements. Some of the kind of more the higher treatments up at the sort of H4, H5, H6 level are fairly nasty chemicals. So we want to kind of limit those to only where we absolutely have to use them. But a lot of the kind of H1, H2 treatments are odorless, colorless, and things these days, particularly when you get into the sort of mass timber space. But looking beyond the code, looking at durability as a larger picture. The expected design life that we mentioned earlier assumes that the timber is fully protected from the weather and the termites. So for it to last 50 years, the code says that we can use timber as long as it's fully protected. But can we assume this? And I think that increasingly, I think we need to question this. Whether we are fully protected, what other mechanisms that we're putting in place in the building, and can we ensure that timber treatment or choosing a durable species is pretty essential. If you're looking at external timber, there's not too many shortcuts there, but it doesn't necessarily solve the original issue if you're looking at internal timbers and things. So we could treat every bit of timber in a house, but that's adding cost. It's adding potential unnecessary chemicals into the environment. So how do we kind of deal with this more appropriately? And I think that approach where defaulting to treated timber for everything is it's kind of very elemental approach. And I sort of believe, particularly as we're getting the timber buildings get more and more complex and the risk level increases, we should be taking a more holistic view of durability. And as engineers, we're very well placed to assess risk, develop solutions. And we can be the ones to help drive these conversations with clients. So, kind of going back to the basics, looking at the timber hazards, the main ones I'm going to focus on today will be sort of water. Looking at both internal and external sources, looking at termites and insects, and then a couple of slides at the end on UV and corrosion. So, where does water come from in our buildings? So typically rain, typically things like leaks. To some extent, humidity and flooding can be issues as well. I'm just going to work through each of these. But why is water important? Water itself isn't necessarily the problem, but it does. The presence of water in the timber, in the structure, can lead to other issues. So Mold is probably one of the first ones that you're likely to see on site. Wet timber provides surfaces for mold to grow. It can happen pretty quickly, and it happens on most sites, to be honest. I've seen a lot of mass timber buildings particularly go up, and there'll be some issues with mold somewhere. It's very difficult to avoid. The mold spores are kind of in the air as soon as you create that wet environment, and the timber kind of provides the food. The mold spores can start to take hold and grow. It's not necessarily a structural concern, but it's something that needs to be kind of treated before the building's closed in, to make sure there are kind of no long-term health issues associated with it. Where it is found in those long-term cases, it's often found more around humidity, condensation, inadequate insulation, leaks through windows and the like tend to be where you'll find mold in the once the building's in service. More more seriously is water can lead to fungal attack, and that's decay, it's rots, white rot, brown rot, all sorts of different exotic fungi, and that can start to occur within a couple of months depending on the timber species, if it's remaining wet. So for fungi to thrive, you need moisture content greater than 20%, you need oxygen, it needs a nice warmish temperature, and it needs the food. So that removal of any 4 of those will prevent it. However, removing the moisture is probably the one that needs the most focus. So looking back at those sort of moisture sources, water or flooding, probably not one that we need to focus on too much. There are some requirements in the ABCB guide for construction of buildings in flood hazard areas, which talks about ensuring that material that's in contact is allowed to dry out. My kind of gut feel for water in flood-prone areas is to make sure all timber elements are projected above high water levels. Timber species are durable or treated, and the components are designed to dry when the water levels recede. So I think there's certainly some areas where we need to bear that in mind, but this is probably more of a kind of niche case. Humidity is one that is starting to come in. There's a lot more focus on things like condensation in the ABCB these days. The kind of short answer for that is avoiding impermeable layers like closed cell insulation or anything in the building envelope that's going to inhibit moisture. The moisture will tend to want to kind of track in and out of the wall depending on the climatic conditions and the internal environments. Mass timber and CLT in particular is one that needs a real strong focus because it is inherently so airtight. So you need to get that specification of membranes and insulation spot on to avoid the risk of kind of inhibiting moisture movement and trapping moisture in the panel. High humidity environments like swimming pools are very specialized, and anyone embarking on projects like that should work really closely with timber manufacturers, with coating and preservative treatment suppliers to help inform their design. Leaks are probably one of the largest ones. So I put these slides up, ask the question, do we have a problem with leaky buildings in Australia? There's some studies that I've read recently that suggest something like 80% or more of apartments built in the last 20 years in Australia have waterproofing issues. So, I think starting to suggest there that leaks in buildings aren't a possibility, they're almost an inevitability. So what do we need to do to be addressing that through our designs, particularly again as we start to push timber into larger structures, apartment buildings, mass timber, the consequences and the cost of remediation and things get so much larger. Basic principles, the 4Ds we call them, great starting point for reducing issues. Deflection, allowing the water to stay clear of any external envelope. Things like overhanging eaves are great for that. Drainage, allowing for any water that does get in the structure to have some ability to dry out, whether that's kind of drained cavities behind cladding or allowing kind of drainage points within your structure. Drying, again, allowing those areas of timber that are susceptible to water and moisture to dry out, and choosing durable materials as we discussed earlier. So leaks can come from just about anywhere. Any kind of junction can be a weak point. But I just want to focus on a few of them quickly, just run through roofs. Overhanging roofs have been successful for centuries. I'm super wary of anything related to parapets and box gutters and the like. It just gives the possibility for water to collect somewhere on the roof, drains to get blocked. So there's a lot that needs to go right for those to work well. One thing that kind of I often try to do in timber structures, again looking at things like CLT, can we set the structure to false? Is it possible to do that as part of the architecture, because it's providing us a kind of backup. So if you're putting in a dead flat CLT roof, and that's going to have a deflection associated with it, so it's going to have low points in there. So water getting in will tend to want to sit there. Whereas if you can fall the structure, any water bypassing your roof can potentially drain out to somewhere in the facade and migrate its way out. What level of redundancy is there in the waterproofing system on the roof? Are we reliant on single membranes? When is that waterproofing system applied? The image there of the CLT slabs actually it's a project from the UK. You can read about it in the Cross. If anyone follows them, there was a problem with a roof on a school building, I believe, which got very, very wet during kind of COVID shutdowns. They came along and put the roofing on after 3 months of it sitting out in the weather, trapped all the water in there. Lo and behold, when they went back months later and found the thing was starting to kind of rot and degrade pretty quickly. So when that system's applied is really critical. Your site controls and making sure that we do those things quickly is important. Green roofs with timber, please just don't do it. I think it just presents so much risk. We need double, triple layers of protection, and if you want to do something like that, there's just a lot of water associated and a lot of risk. Balconies, I'd question whether timber balconies are appropriate in the first place. Similar to roofs, can you set these to falls? And what's your backup plan if the membrane fails? So the picture at the bottom is a real project that I've been involved in, where there was a CLT balcony, had a single membrane on top, but that membrane kind of failed, and the water was able to get in, track in under the membrane, and then between the CLT and the plasterboard, fiery plasterboard underneath. The problem there was it wasn't a lot of water getting in every time, but it was very, very difficult for that water to get out. So it was significant volumes of water trapped in there for a significant amount of time. And one of the other aspects of that is how long does it take before that is visible? It can take several years potentially for water to be able to kind of make itself known. So if you are doing things like mass timber balconies, just be really, really careful. Make sure that you're going kind of belt and braces with waterproofing. How are those inspected or remediated? I've sort of started to see a lot more kind of pod and paver type solutions specified for balconies. I think it's a really good solution for timber. It gives us the capacity to lift up pavers and to look and inspect and remediate if there are problems. And then going back to that question around design life and remediation, if there is a problem, how easy is it to remove the damaged panel? So looking at that detail at the bottom, that's a sort of detail that I used to do on projects where panels, set downs of balconies tend to overlap, and you screw through to both, and it's a nice robust detail. But that balcony panel, if that's ever going to need replacing, is an absolute nightmare. So do we look at other systems where we take those higher risk areas, whether it's a balcony, a wet area or something, and give ourselves the possibility to remove those simply. Wet areas, again, relying on single membranes in these is again fraught with problems. What's the design life of that membrane? So if we go back to our initial question about design life and the assumption that the timber is going to be protected. What's the design life of our membrane? Is it 15 years? So, is that going to be replaced after 15 years? What is our kind of mechanism there? So I'm always kind of asking myself when I'm designing these things, what happens if it fails? Where does the water go? And these are the sort of, the sort of guiding principles whenever I'm thinking about leaks, about putting, minimum 2 levels of protection in any high risk areas. Now, whether that's a membrane and treatment to the timber, or whether it's 2 layers of membrane, or whether it's a waterproofing system and active monitoring. Always got to ask yourself, how do you protect against that? Because I don't think there's any way that we can guarantee that those membranes and that protection is going to last the design life of the building. Always got to ask yourself where the water goes if it leaks, and how long before a problem is known about. Particularly domestic or apartment buildings, we have large build-ups below the slabs for acoustics and fire. It can take a long time for water to migrate through those. At an office building that potentially has more exposed feet, that one you're slightly likely to get notification that there's a leak much faster. So, having that kind of nuanced conversation is really important. Rain during construction. This is something I'm getting called into a lot at the moment. Significant problems can be caused by timber buildings getting wet. And I'm seeing a lot of notes from engineers that are just kind of impossible to comply with. I've seen this note on a number of drawings which says, the builder is to maintain all timber below 14% equilibrium moisture content. And I kind of go, how do you expect to do that? Even building that undercover at certain times of the year, the EMC of the timber is likely to be above 14%. So we need a more nuanced approach to moisture measurement. Where are those measurements taken? How are they taken? Often they're taken with moisture meters that aren't calibrated and things. So we need a kind of more nuanced system, and I'm sort of advocating for more of a kind of traffic light system, which looks at moisture content in time and depth of reading as sort of much more of a kind of matrix approach to say, where do we need to start to take action? Where do we need to think about remediation? And where do we not have to panic? Focus on the junctions when we're looking at rain. They're going to be the weakest points. There's a great guide there by RDH, which I'll probably reference a few times in this talk. But it's well worth looking at, particularly for mass timber buildings. Taping joints should be absolute kind of basic for mass timber. There's a picture here of kind of 2 examples showing what happens if you don't tape them. You get a lot of kind of moisture drawing up walls and things through capillary action into the base of your walls. It's not the be all and end all, but it does provide a lot of help. It can depend on the application, and the putting tapes on only works as long as you keep the moisture out. Once the moisture kind of gets in under there, and the tape's actually preventing the timber drying out. So you need to be very careful about on site how those are applied, whether there's capacity for the water to kind of track in through through joints in the timber and the like. Increasingly seeing more and more slabs and things protected with membranes, and always remember any visual aspects. So we water staining, molds, that sort of remediation of those timber elements is very, very expensive. Advocate during construction to have a kind of moisture management plan, trying to work out where the timber drains to. When the contractor is actively kind of sweeping water off the floor after rain events, where does that get swept to? Where does the water kind of want to track to? See a lot of issues with water kind of draining down to the face of columns or something through tolerance gaps and causing significant kind of checking. But it's not just a visual damage or long-term opportunity for rots, but tolerances can be significantly impacted too. So, one thing that I this is a real project. I won't say where, but there was an LVL floor system that was designed. It was a series of sort of 1200 millimeter wide plates. It got very, very wet over a weekend, and it was kind of shocking how much the thing grew. So the whole floor plate grew and pushed walls out of plumb. So it's understanding those tolerances and how water impacts that. Making sure that we're designing those into our buildings that we don't have any issues. Rain during construction can also affect screw capacities. There's a really good guide, the Smart Screw Book from Rotherblast, which talks to some of this stuff. But draw attention to the one on the bottom right, which is sort of steel plate hanging a timber beam and getting wet. That change in moisture content is pretty well doubling the load on that screw as the timber is growing and kind of putting tension in there. So being super careful about how we protect and how we design and specify those screws. And when we apply finishes is also super critical. We've got to allow the timber to dry out. The timber frame typically would be about 18% or less before you start applying finishes, but mass timber should ideally be even lower. Because it's much more solid, there's much more water in there. There's less ability for the water to diffuse. We should be trying, specifying that any kind of mass timber elements are kind of for low moisture content before we start to put impermeable finishes and things on them. Again, that RDH guide, please read that; it's awesome. But we're starting to, implement kind of what we call moisture in design. This is my kind of pet subject for the moment, where the same way that we would take a kind of safety and design process, we adopt a systematic approach for risk assessment for moisture management. These sorts of risk matrices are pretty familiar to most people. So going through the project element by element, both in that permanent and in the temporary case, looking what the risks are and what the mitigation measures are, and working through that as a design team, I think is going to be super important. There's some great flow charts in there looking at different ways of building roofs and floors, and particularly when you're getting more and more complex, more kind of large scale structures, the mass timber structures. This is an approach that we need to be trying to run with our design teams and builders. Touching on termites now, as I said, the NCC's got a fair amount of information on this. Refers back to AS 3660, which is the termite protection code. But effectively, all states and territories except Tasmania have designated termite-prone zones. They're particularly more active the further north you go. But the risk of attack varies according to the location in the house, and there's site-specific elements to all this. There are different types of termites. Subterranean ones are the most significant and most common. They're the ones that require contact with the ground, and there's a range of treatments there, including isolation. Some of the other ones, drywood termites, don't necessarily need contact with the ground. They're present more in the far north, and treated timber is really the solution there. Beetles and borers, probably less common, but still an issue. They lay larvae in the timber and they kind of eat the timber as they grow, and you'll only see signs rarely after the larvae has left them and then leaves little pockmarked little holes in the timber surface. Two main options really for protecting timber: either the provision of barriers in accordance with AS 3660. These can either be physical, chemical, or other barriers. Timber should be kept clear of the ground, and slab details at edges around penetrations need to be treated either chemically or with mesh or things like that. Or you're choosing termite-resistant materials for the primary building elements, either termite treatment or termite-resistant timbers. Is a picture, so you'll probably be familiar with treated pine framing. The kind of blue color is pretty prevalent, but every different manufacturer will tend to treat them, and those dyes are put in to allow you to see and as a branding exercise as much as anything. When we get into mass timber, it becomes a little trickier. The local suppliers can offer treatment typically up to H3 to meet Australian standards. That's often impregnated into the timber before pressing and gives high levels of protection after cutting. Overseas suppliers, most mass timber species, spruces and the like, can't be treated through impregnation because they've got a much denser cellular structure, so they tend to rely on envelope treatment. So site cutting, weather exposure, things like that can be an issue. So if you want to look at overseas supply and looking at sort of termite protection, then you need to check with the supplier what options are available and compliance with Australian standards. It's an area that's still kind of evolving, and it's relatively new that suppliers are offering these sorts of treatments into Australia. Some of the other hazards, ultraviolet sun exposure, typically not a structural issue, but it does cause visual aspects. It can cause checking in some extreme cases, particularly if the timber is allowed to get very, very wet and then gets very, very dry. I see sort of cracking, checking columns, particularly where they're up against facades and they're subject to a lot of kind of sun. In the permanent condition, they can dry out to a very low moisture content and can tend to lead to checking. Most cases, it's not a structural issue; it's a visual one. But in some extreme cases, where timber has been allowed to get really wet on site, then it can prove to be a more structural issue that may need some remediation. Timber can change colour super quickly. Particularly pine has a real bad habit of that, but spruces and all sorts as well. So when you're looking at visual panels, visual elements, making sure that we protect those as soon as they're in on site. Things like propping, making sure that we're protecting those areas. Otherwise, you end up with a kind of just a white patch of where your prop head was and a kind of bleached panel over the rest of it. So that's not a structural issue, but can lead to a lot of kind of cost in remediation and recoating or sanding. Connectors, screw specifications, things can be super important, particularly if you're using something like treated timber. There's different coatings available from different screw manufacturers that are suitable. Galvanized coatings don't really cut the mustard, particularly if you're near the coast or using kind of some of the more aggressive treated timber. Making sure brackets and plates are considered, whether what level of galvanizing they have, how they're protected from water. Designing to try and avoid moisture traps. There's a few kind of details that again I've come across on some recent projects where just considering how where does the moisture go on site. Making sure that there aren't kind of pockets and things where it will sit and not be able to dry out readily. So, asking yourself all the time when you're drawing details, when you're designing structures, when it rains on this inside, where does that water go? Is it able to kind of track somewhere and dry out? So yeah, that was a bit of a kind of a quick overview of durability and timber and some more practical tips. As I said, I think I believe that engineers need to be leading this conversation. I think we're the best place to be able to kind of drive this and to have those nuanced conversations. As we're getting larger and larger buildings, I think we need to take a more holistic approach to durability, not just an elemental one, which defaults to treatment. It's not the silver bullet for timber durability. It may solve some issues with potential rot, like it will buy you time. It won't necessarily stop other things like expansion. It won't stop things like mold necessarily. So we need to be actively kind of managing our design team, our client, to make sure that we're protecting our timber and that we can rely on it for the design life of the building. I see this a lot with projects I'm involved in. Trying to save a few bucks up front by skimping on a membrane or kind of cutting out a coating. the remediation costs down the track are many times what the original kind of saving would have been. So really want to advocate for better protection, for taking that extra care of it up front. You'll pay for it down the track. Insurance companies are also looking at this far closer now. Durability in all structures, but timber in particular has got a lot of scrutiny on it. So making sure that we're taking an active approach to this, and is going to mean that we get more buildings in timber over the line, and that they're fit for purpose, and we get to enjoy them for centuries to come, hopefully. Lots of great resources available. I already talked through Wood Solutions. Timber Queensland has a lot of really great stuff, particularly in that domestic housing side. The RDH Moisture Management Guide is awesome. BM Charter in the UK has lots of really useful papers on timber and moisture management, which are again freely available. And then speak to the timber suppliers, secondary product suppliers, with their membranes, coatings, fixings. Can offer a lot of really, really helpful information for project-specific designs. So thank you. I'm Nick Hewson from Arboralis on behalf of Wood Solutions. So please visit the website or follow them on social media. And a small plug for my own Timber Dialogue, which is a free-to-join organisation which gets together kind of every 3 to 4 weeks and works through a topic relating to timber and provides some guidance and some discussion around particular topics. So please feel free to join that if you'd like to learn more. But thanks for listening, and looking forward to some questions.
Thank you, Nick, for a great presentation. And just apologies to our audience that we had a few technical issues at the start. So thank you for your patience. I think it's that time of year. It's now your turn to get involved. Could you please ask Nick questions via the YouTube chat box? And thank you for everyone who put forward a question while registering. So we will have 20 minutes of Q&A, which is what we planned for. That will just take us over past 2 p.m. today. So without further ado, Nick, can 100-year design life be achieved with timber? And that question came in from Daniel, watching in New South Wales. Thank you.
Yeah, absolutely it can. I think, showed some pictures of some examples earlier in the presentation, which showed, buildings that have been in existence for hundreds, if not thousands of years. So if we take care of it properly, absolutely can last that long. Certainly there's some glulam buildings. I think one of the earliest kind of engineered timber glulam buildings is in the UK, and that's over 120 years old now. So even in that sort of mass timber, engineered timber space, there are examples now which are as old as the material itself. So if we can kind of follow the guidance that we talk through, if we can protect from water, from insects and things, then there's no reason that timber structures can't last hundreds of years.
Thank you. And over to Victoria, we've had a question that came in from Karen asking you, Nick, can you please share your thoughts on how to counter resistance to the use of GLT/CLT for building structures that are not in a conditioned temperature-controlled exposure that require a design life of over 50 years? Thanks, Nick.
I think the important thing with a lot of mass timber is going to be protecting it from a direct weathering. If you can kind of take care of the weathering and the termite protection, then the timber that's in an external but protected environment, we can predict what the equilibrium moisture content is going to be on those. And I'd say for probably the vast majority of climate zones in Australia, like there will be a kind of natural variation of somewhere between 10 to 15% equilibrium moisture content of the timber in an external but protected environment, which is well within the sort of operating range that these products are designed for. So I think as long as we're kind of keeping them protected, keeping them dry, if there is that kind of chance for wetting, that they are allowed to dry out, then we don't have a problem with it. I think where we do have issues with external timber is where we're letting them get wet and then where they can kind of stay wet. So always making sure that there's we're designing to allow airflow around these. We're designing to avoid moisture traps in details and making sure that we're able to kind of keep that timber reacting with the atmospheric humidity. Then there's absolutely a possibility that those will last for 50 plus years.
Thank you for that. We've had a question that's come in from Damien, who's watching from New South Wales. Good afternoon to you, asking, if I use structural CLT externally with H3 treatment, when should I expect to need to replace it? Thank you.
So again, I guess it's dependent on the level of exposure. If it's protected from direct wetting, that should last 50 to 60 years. There's no active mechanisms to degrade the timber. I've got some experiments that I've set up in my own backyard, and obviously previously in my career I worked for XLAM, and there are panels over there in the New Zealand facility that were out in the weather for 10 plus years, which were still going strong. The biggest challenge I think with the engineered products is not necessarily the durability of the timber itself, provided it's sort of H3 treated. Should have a really long design life, and I'd encourage you to take a look at the timber durability guide from Wood Solutions. That'll kind of give you an idea of anticipated design life. But particularly, glulam, not so much. Particularly with CLT, I think one of the challenges with a lot of kind of weather exposure, cyclic conditions over time, a lot of wetting, can be the actual kind of bond between the layers. I've seen certainly some examples where certainly the edges of panels, you can get a bit of cupping, you can get sort of breakdown in those glue junctions. So making sure particularly edges of panels and things are protected, whether they're sort of capped or waterproofed in some other way, will go a long way towards making sure that anything you do want to use externally is going to last a long time. But like I said, we've had CLT walls built at XLAM which lasted decades. They grey off pretty quickly and they start to look a little bit rough. But in terms of carrying on doing their job, they're still working very well.
Thank you for that, Nick. Question came in from Rovert in Victoria. It's a great question, asking you, Nick, what are the most common mistakes made in timber durability?
Yeah, I think I guess it's a fundamental question of the presentation. I think it's not overtly acknowledging durability at the start. When we're taking on a timber project, I think durability should be one of the first questions that we should be asking. I think that there's a lot of tendency for to push the responsibility onto architects or to builders. The specification notes that sort of say builder to deal with all the waterproofing. But I think as a sort of as a profession, like engineers, we need to be kind of much more active in that space. We need to be pushing that. I think the biggest one I see for mass timber in particular is water. We've not done a great job of dealing with water in mass timber so far in Australia, and there's a number of projects that I'm aware of that have had issues, and I'm involved in sort of remediating some of them. And I think that we need to acknowledge that it is a material that does need to be kept dry, that does need to be does have sort of higher consequence of failure, particularly when we're looking at some of these larger buildings, and we do need to kind of go belt and braces on the detailing. We can't rely on a single membrane to protect our CLT for 60 years. Like that membrane will be lucky to last 10 to 15 years if it's installed absolutely perfectly. So always looking at what our kind of hierarchy of controls are, and how many what's an appropriate level of response, and how many kind of layers of protection do we need to put in place over that to make sure that that's going to last the 50, 60 year design life and beyond.
Thank you for that. Over to Queensland, a question from Sivash asking, Nick, when combining timber with other materials in hybrid structures, what are the best practices to ensure the longevity and durability of the timber components? Thank you for that question.
Yeah, it's a really important one. And I think anyone who saw my presentation a few months ago on hybrid structures, there's some discussion about it in there, but sort of focusing on that durability space. I think understanding how the different materials, whether it's steel, concrete, masonry, how they react to moisture, temperature, and managing that interface. Like, I'm always keen to try to separate the timber where I can from particularly something like concrete, which can be quite porous. Where we have steel structures, maybe a kind of hybrid with timber. Making sure that the detailing is not such that water's tracking in through different joints and junctions to find its way into the timber. Making sure that whatever interface, whatever junction detail we have between them is capable of kind of shedding water and not trapping it. So yeah, I think it's going to be particular case by case basis, but I mean the big ones I find are kind of concrete. Using screeds or concrete toppings on slabs, making sure that there's a really robust impermeable layer between the timber and the concrete to make sure that we're not kind of tracking water in, and we're not leaching water out of the concrete when it's curing. And at the bases of buildings, typically we'll have a concrete slab and potentially a CLT wall or something sat on top. Those CLT walls, the end grains of those should be treated or wrapped with a kind of DPC. Seeing a lot of projects where water's kind of collecting on the slab somewhere, and the timber behaves like a kind of straw, and it just sort of sucks up the moisture through the end grain. So managing those interfaces around there and making sure that we're protecting those vulnerable parts from the timber from taking on moisture from other materials.
Thank you for that, Nick. Question has come in, what treatments can be applied to CLT timber structure to prevent mould growth until the buildings are watertight? Thank you.
Look, it's a big topic of discussion, and one that I've sort of been passionately sort of advocating for the last couple of years. And I think if you're going to go to a timber conference and hear discussions from the people who have been building these on site, that water management on site is amongst the most challenging aspects. The two main ways that have been successful. One, talking about kind of treatment to the timber, so actually pressure impregnating timber with an H3 treatment. So both local suppliers, Xlam and Next Timber, can offer that, and same goes for glulam suppliers as well. Overseas ones should be checked, so that that will help to prevent excessive damage, and to an extent sort of long-term kind of rot or mold issues. I think in that sort of construction phase, some of the best things you can do is apply membranes to the slab. So more and more seeing the variety of products. There's Rothoblast Defense, there's Cedar Wet Guard, those sorts of things. So it's applying a kind of an impermeable or semi-permeable sheeting to the top of the CLT slabs that just protects the slabs from the water. It means that when you come and you've had a big rain event, the water's sort of pooling on the surface, and then you can kind of brush and squeegee that off into drainage points, because one of the biggest kind of impacts that I see on site is having to remediate these panels after, or having to wait a long time before you can apply finishes. So on the projects I've seen recently, it's far cheaper to pay the extra for those membranes up front and protect it, rather than trying to remediate things down the line or impact the program and things like that. So I'd say that the vast majority of buildings I'm dealing with these days, particularly at that larger commercial scale, are opting for some level of protection on top of the CLT slabs.
Thank you for that, Nick. A question's coming from Karen asking about standards and codes, and Karen's asking, what about engineered timber durability, glulam, CLT, etc.? What standards codes are available that go beyond 50 plus years or up to 100 to 120 years for significant architectural buildings or major projects? Holistic.
Yeah, like it's pretty challenging to find that sort of information out from codes and standards. As I sort of showed at the start of the presentation, AS 1720 doesn't have a lot to say on the topic. It's sort of it says that the timber should last the duration of the building, provided it's protected. So I think it's about making sure that we have genuinely protected it, and there is enough redundancy, and that we've worked out those maintenance regimes and things. Certainly, another guide that I found really useful for these sorts of questions is the timber sort of Wood Solutions Timber Durability Guide, which it's available for free from their website. But that gives some indications of design lives for different species in different atmospheric conditions. So certainly some of those are well in excess of 100 years if they're protected and treated well. So there's certainly some evidence out there. When you get into that engineered space, we haven't been building engineered buildings for really long enough. As I said, there's some examples from early glulam projects which are 120 plus years old. So there's certainly evidence there, but it's still kind of growing. I know brands in New Zealand are spending a lot of time at the moment, doing some, a lot of timber durability testing on engineered products, and certainly there'd be a great opportunity to see what they're doing, and some accelerated aging testing and things like that. So it's still emerging, but I encourage you to take a look at the Wood Solutions guides.
Thank you, Nick. A question from York is asking, what are the typical grades of timber used in timber frame domestic construction? Are there time limitations for exposure to the weather before the roof is placed over? Thanks, Nick.
Yeah, there was a question as well earlier on that I saw that I think I want to tie into this one, which the timber species that we use to sort of domestic frame construction has changed significantly from hardwoods and things 40, 50 years ago, but now the vast majority, 95% of our timber frame buildings we built from pine. From Australian pine, or in some cases kind of European spruce. The treatments for those are available from different suppliers up to sort of H3 quite typically. The timber grades themselves are MGP 10, machine grade pine is probably the most commonly graded one. I encourage people not to specify 12s or 15s unless they're really sure that they're available. But pine is the most common. I think for domestic frame construction, there should be no issues in the timber being exposed for months during construction. As long as it's allowed to dry out, and you don't have any kind of moisture traps in there, and as long as you make sure that any kind of rainwater or high moisture level in timber is it's allowed to dry out before you start putting finishes like plasterboard on, because that can lead to trap moisture, molds, and things like that. I think one of the bigger areas that I see issues for is probably not so much the kind of actual structural frame. It's on things like sheathing and flooring. So like yellow tongue flooring or OSB bracing and that sort of stuff. I think there's certainly, from some projects I've seen around me getting built, when they're left out for extended periods of time, I do have some concerns with durability over those. So I would be always keen to make sure that you weren't putting flooring on or sheathing on until you were sure you were going to get the building closed in and the roof on pretty quickly, and not leave those exposed for significant periods of time. Otherwise, potentially looking at strap bracing or something as an alternative to sheathing if that was potentially going to be an issue. But for a couple of months exposure on site, then that shouldn't cause any issues.
Thank you, Nick. Thank you. And we are getting to the end of our Q&A, but we have a question from Hanson asking Nick, what are the current chemical treatments for mass timber in Australia during production and on in-service timber bridges? Thanks, Nick.
Yeah, so I think the sort of major suppliers in Australia would be able to offer up to a sort of H3 treatment typically. So H3 would be exposed to some degree of wetting, but not in contact with the ground. So H3 would cover a kind of protection against your sort of rots and molds and funguses and things, as well as kind of insects like termites and things. So every manufacturer has their own kind of secret herbs and spices recipe for their treatment. So engaging with them to understand, but there'd be components of permethrin or similar for termites. There'd be boron for lower levels of protection, and other kind of products for higher levels of mold and fungus protection. So I think one of the kind of big questions with the treatment is how is it applied? Like their pressure applied to the timber before it's made into the mass timber. That provides a kind of a solid level of protection throughout the whole section. So when you're kind of cutting or making holes in the panels to put them together, that you're still kind of protected. Or if it's an envelope treatment, where you need to process the material first and cut all the holes, drillings, rebates and things in it, and then pressure treat it. They've both got their kind of pros and cons to them. Just be aware if you are kind of envelope treating something that if you do make any site modifications, that you should be treating any newly exposed timber that you've cut through into. So that's particularly relevant for some of the European suppliers who are in the market now and offering treatments. Is they tend not to be able to pressure impregnate the timber itself, and they would envelope treat. So always making sure that you've kind of got a backup on site if you need to modify anything or cut anything down to size. So just be aware of those.
Thank you. Today we've talked about timber durability essentials for engineers, and Nick and we spoke a little earlier about what an exciting field it is and some of the challenges. On behalf of Engineers Australia, what advice do you have for our young engineers that are coming through?
I think it's just grab every opportunity you can to get out and experience it. Particularly the mass timber space, I think is absolutely fascinating. It's growing at a rate of knots. Like we're about 10, 12 years into our sort of real modern mass timber journey. So still very new, still a lot to learn. I'm a big passionate advocate for any opportunity to get out to suppliers or get out on building sites. So you'll learn so much from those that'll really turbocharge your development. Engage with organisations like Wood Solutions, Timber Dialogue, and those sorts of people to learn more and to connect. But it's a really exciting area to be in. It's been a kind of great career for me in this space, and I'm really excited to see where the next decade takes us.
Thank you. Exciting stuff. It is all the time we have for today, so please join me once again in thanking Nick Hewson for his time and presentation. It was fabulous. I'd also like to thank Engineers Australia's industry partner, Wood Solutions, for their support. If you don't mind, as always, take a couple of minutes to complete a short feedback form, which is linked in the description box below. Helps us to improve and plan for future sessions. Thank you again for joining us, and I look forward to seeing you at our next Thought Leaders event. Thank you and good afternoon.